All right, good morning, everyone. Today we're going to be talking about chatbots. This is going to be our introduction to AI module. And in this module, we're specifically going to concentrate on how exactly what is AI, how does it work, and throughout the process of this module, we'll go ahead and create a couple of different chatbots. We'll create a rule-based chatbot, and we'll also create a retrieval-based chatbot. With that said, all of that shouldn't really have any meaning as of now. Let's start talking about or AI in general, right? Starting off with, well, what is AI? Nowadays, when everybody references AI, they're usually referencing something called ChatGPT. And I like to break this up into two categories where we have our traditional AI models, and then we have our, I guess, modern AI models, right? So let's talk about modern AI and let's talk about traditional AI. Now, artificial intelligence, could anybody tell me or give me an example of what that means to you? What is something that you would classify as artificial intelligence? Open-ended question. All right, let's hear it, Alex.
I don't know why I raised my hand. Uh, Something that has the ability to maybe reason or understand some type of logic that's not human.
Okay, nice. So we have something that's able to understand logic. Let's go ahead and break that one down. So capable of understanding. All right. Now, in order to be able to capable to understand, would you also classify the ability to be able to learn as part of AI? Okay, I see a couple of head nods there. So capable of learning through interactions. Now, I break this down as traditional and modern because again, when we talk about modern AI, we have a pretty good example in regards to, hey, we have things like ChatGPT, which is just OpenAI, where it's a prompt-based chatbot that, oh, hello, users can interact with. We also have Gemini, which again, a prompt-based chatbot that users can interact with. Now, artificial intelligence went back in the day, kind of got a definition where essentially it was classified by a machine being capable of, I want to say, fooling or tricking other humans in believing they are speaking to a person. All right. Now, in my opinion, when I speak to OpenAI, I think it does a pretty good job at letting me know, hey, this is a person. But we've seen these kind of examples of modern AI before even ChatGPT became a thing. Can anybody think of a couple of examples where you're speaking to a machine that's trying to mimic human-like behavior?
Our phones,
Okay, phones. What do you mean by phones?
like when you talk to it, whether it's I forget all their names. You just ask them for something or to do something, and they just kind of understand and perform it.
Okay, great. So something like Siri, right? When I say, "Hey Siri," oh, I shouldn't have said that. Okay, that didn't trigger anything. But I use the phrase, right? And then Siri comes back and says, "Well, what would you like?" And I say, "Hey, play this song on Apple Music." And all of a sudden, the song starts playing on Apple Music. Okay, good. There's one specific example. What about when you're being handled through customer service? Right? Your internet goes down, you call AT&T, and then what happens? Usually takes a while before you even speak to a person. It feeds you to a machine, and then you have to deal with, sorry, I cannot understand you. Please say that again for probably another 10 to 20 minutes, right? Okay, so those are a couple of different examples of chatbots. Some of them are text-based, where I'm actually writing text and sending it over to some sort of machine or server. All right, at this point, we did our full intro to full stack, so we understand what a server is. And it works almost exactly the same. I am writing on a form, which is what is happening in ChatGPT. I am submitting that form. That form sends my text over to a server. That server feeds that text to a learning model, and that learning model generates text that gets returned as a response. Now, we saw that process happening with the students where if I go to refresh my page, a request gets sent from my HTML form to my Flash server, it queries the database, and then a JSON comes back to me. So it's almost the same exact process. The only difference is that there's a learning model in the process rather than a database query. Now let's talk a little bit about traditional AI. What did AI look like before we started interacting with what modern AI is nowadays? Well, in traditional AI, usually what we're talking about is machine learning and just pure machine learning, which is, although not a super popular portion be prior to ChatGPT, it did exist and it was very well researched continuously, trying to figure out how we can actually teach a machine to learn. Well, these older traditional models were utilized in many different ways. A common example is, let's say we go back to the time when MySpace was a thing, or when Facebook, when we first started uploading images into the internet. Well, a problem arose where inappropriate images were being posted. Now, when those inappropriate images became an issue, binary models started to become a thing, where images were broken down and would return a Boolean value to state whether that picture was appropriate or not. If the picture wasn't appropriate, it would simply just get removed. And it would get feed through some sort of learning model. Now, as social media became more popular, we also had something called multi-classification models. And these models would analyze text to then interpret intent of text. And the purpose of interpreting intent is, hey, is this message a harmful message towards other individuals? Is this clarifying some sort of hostile format towards someone else? And these machine learning principles of binary models and multi-classification models is pretty much the basis as to how modern AI is now achieved. Now, if we want to think about a something more to heart nowadays, if you, I'm sure the majority of the individuals here have Facebook. If you take a look at your Facebook, somewhere in settings, it will actually tell you what your preferred Democratic party might be or what you fall into there, or excuse me, political party might be. So you could go in there and search it up, and just by looking at your behaviors on social media, the things that you like, the things that you share, the people that you follow, the people that you have as friends, it can tell you more than likely who you associate with. And it's also how the algorithm determines what kind of content to show you. It's always looking at your behavior and it's actually learning through your behavior. Now, before we start talking about how it learns and everything else that goes in behind the weeds, I want to talk about how chatbots were created, their history of chatbots, and then we'll talk about how each one of them is actually able to determine an answer. So, starting off with the very first chatbot ever created, or the very first AI that we saw. In this case, it was named Eliza. Now, Eliza was created in the 1960s, I believe, and its primary purpose, or its only purpose, is to mimic a psychologist. The person who created this program basically did it through a decision binary tree. There is a set of predetermined responses that are available to this chatbot. It's not learning, it's not trying to come up with new material to give you. It's quite literally just going down through a ridiculous amount of FL statements and trying to figure out which answer would actually match what it is that you texted. Now, how does that work? Well, as you text or as you write text that you would send over to Eliza, Eliza would then break down through regex, which we'll learn about later on. Regex is a tool that helps you parse through text, and this is falls into the natural language processing system, which we'll talk about here shortly. So through regex, it would highlight what are the key words that are happening inside of this text. So for example, here we have what are your hours? It would disregard are and yours and just analyze that you're asking a question of what, and then it's realizing that you're asking for hours. So it goes through the decision tree, analyze the keywords. Okay, keywords are there. From there, since this is a specific model mimic to only accomplish one task, it's easy for us to actually create a decision tree for it, which in this case, it's either staff or hours. Well, I want to say, hey, I realize the hours is present there. Well, what are they asking for? Are they asking for what or when? But they're asking for what? So from there, it's able to decide, okay, they're asking for what hours. And then it can return our current hours of operation are from 7 to 5. Right? It's just falling through a simple tree saying if or else and trying to figure out which answer would actually match what you're looking for. Now, this process is a bit more complicated as to what happens in the background. Again, this is called natural language processing. But when it comes to Eliza, Eliza was its one purpose was to mimic a psychologist. And when it came out, the person who actually wrote this was trying to figure out, is it possible to achieve intelligence or achieve the purpose of AI, which is to have a person believe that they're speaking to another person through a machine. So they went through, they collected a ridiculous amount of data about the psychologist, what kind of responses they would give out. And then they created a bunch of data as to what are the common interactions that a person would have with this psychologist. And after looking at all that data sets, they were able to create these binary trees that would essentially ask if or else statements all the way into being able to come up with a possible answer. Now, weaknesses as to what Eliza or simple rule-based chatbots, this is called a rule-based chatbot, can accomplish. Can anybody think of any sort of limitations for this or obstacles that you may come across whenever you're trying to create a rule-based chatbot?
Trying to define the massive number of keywords that people could use.
Okay,
So
great.
building that library would be hard.
Yeah, so you yourself would have to determine what are the keywords that we're looking for. And in order to determine those keywords, you would need a lot of data to essentially scrape through to then afterwards determine. I think a common process for this would be, hey, I collect all of the customer interactions. I look at all the customer logs specifically, not the responses, but just the customer logs, and analyze what are all the questions that are usually being asked. From there, after analyzing all the questions that are usually being asked, I can determine what are the keywords within those questions and then build that library. Now, as a programmer, when you're writing all these if and else statements, you got to realize that this is probably very time consuming, right? It's a lot of hard coding, regardless whether you're utilizing regex or not to parse through text and determine information. There's going to be a pretty good ridiculous amount of time that you're going to spend just trying to make sure that your model is behaving the way that you need it to behave. Now, on the opposite side of that, some of its strengths is that you are in control. There's no unexpected behavior as to why your model might not be returning an answer, right? Other than the fact that you might have created a syntax error some way, somewhere inside of that binary tree. But in reality, it's up to you to determine what kind of responses are being returned by this model. A rule-based chatbot is completely in your control. You have all the tools to interact with it, and you decide what kind of responses are returned through it. Now, with that said, here we have Eliza. I was able to find a running version of it. And again, its purpose is to mimic a psychologist. So I can say something like, let's go and I say hello. All right, how do you do? Please state your problem. I currently feel overwhelmed. I think I can spell that correctly. So then it says, I am not sure I understand you fully. It's trying to encourage me to elaborate more on my problem. Okay. I don't think I'm getting enough sleep. And then it again tries to encourage the conversation, says, don't you really think you're getting enough sleep? And no, I don't think so. It's asking me if I'm asking, no, I am not. And then it tells me I'm being a bit negative. So you can see how it's being restricted as far as to what kind of interaction it can have with you. Although it is encouraging me to have more of a conversation with it, it's having a little bit of trouble trying to be, for lack of better words, dynamic, right? And even though this is up and running, it's not learning. At no point is it retaining my data to try to change its algorithm. It's just simply taking my text, highlighting for keywords. So, for example, here I said getting enough sleep, and then it tells me in my response, you don't think you're getting enough sleep. This part of don't you really think you are is probably some predetermined text that's already inside of the model. And then it's just grabbing the keywords and asking me them again. And if it's not able to tell what exactly it is that I'm stating, it just tells me I'm not sure I understand you fully. All right. And it's also able to realize that I'm stating negative intent. When I say no, I am not, it's able to tell me that, hey, you're being a little bit negative. So it's breaking down all of the text, analyzing for keywords, breaking it through its decision tree, and then giving me back its best capability for a response. All right, so that's Eliza. I would like for us to take a little bit of time to mess around with Eliza, just so you could see the capabilities and limitations that it has. I shared Eliza's link inside of Slack, so everybody should have access to it. Currently, it is 9:33, or excuse me, 9:39 now. Let's go ahead and come back. Excuse me, 9:34. Let's go ahead and come back at 9:39 and continue on with our lecture. So let's just take these next 5 minutes to just ask Eliza a couple of prompts, maybe get a cup of coffee, and see if you get a laugh out of interacting with this model. All right, thank you so much, everyone, and I'll see everybody back in 5. Perfect. Welcome back. I hope everybody had a good interaction with Eliza and you got a good kick out of it. And hopefully that gives you a little bit of an image as to what its capabilities and limitations truly were back in the day. Now, keep in mind, this was created in the 1960s. So it's actually really impressive for the time that it was made. Now let's talk about Alice. All right. What is Alice? Alice is actually a retrieval-based chatbot. And the biggest difference between Alice and Eliza is that Alice isn't just a one-stop shop. It doesn't come with one specific task. Because it's a retrieval-based chatbot, it actually has the capability to account for knowledge that happens anywhere, or that can give you, it can just achieve multiple, hey, what is this? And it's able to give you a correct answer. Now, why or how does that happen? There's still a breakdown of keywords that comes through. When Alice receives the prompts, it breaks down those keywords, and we can see that those keywords get generated down below. Now, as those keywords are generated, there is a comparison, a mathematical function that happens with all of its stored answers that it currently has. Right? And as it's asking all of its stored answers, hey, which one of these has the best match? It actually determines in percentages how much does it match with each one of them. Now, they don't add up to a total of 100%. It's just simply asking individually, what kind of match are we looking at? It could be a 10% match, a 30% match, 10% match. Now, rather, this is more of a categorical thing. After it would match with a topic, after matching with a topic, it would match with a subtopic, and so on. Right? This is just a dumbed down version, or excuse me, a very high level version as to how it would produce an answer. But you can see that you can ask it something like, hey, what was the first president of the United States? And when you ask it like that, when you ask a question as such, it would break down the keywords. In this case, first president of the United States and who, which is the keyword as to what it is that I'm asking. It would then compare to all of the possible answers that it has to give you, come up with a percentage. And when it matches the right answer, or excuse me, its best matching answer, it would return that to you, telling you, hey, this is it would be George Washington. Now, um, when it comes to what the not only is there a huge difference in capabilities between Eliza and Alice, something that completely separated the two is that Alice came out once the World Wide Web was actually a thing. So once the World Wide Web was developed and we were able to obtain data from hundreds of individuals, it really gave us the power to take AI to the next level. All right, give us more information, break out of these one task driven rule based chatbots and create a retrieval based chatbot. It is not generative, it still has a set of answers that are available to us, but we also can't hard code this binary tree to be an if else statement to try to fall into everything. So instead, it runs mathematical operations in the background to figure out which text would be its best match. There's a couple of common practices that we'll learn here later on, which is like the bag of words practice to try to break down how bag of words can percentile to one another. We'll also utilize scikit-learn to steal a couple of libraries and extensions from it and apply it to our chatbots so that they can learn better. And let's go ahead and take a look at what Alice actually looks like. So if I open up Alice here, you can see that Alice is just existing in the HTML. And just almost exactly like ChatGPT, it has a form that I can insert my prompt to, and I should receive back a response. So let's see, who was the first president of the United States? All right, so I ask a response is sent to a server. That server then sends my query into the model that is trying to acquire some sort of answer. It runs its percentages and then it finds out which one is its best answer. In this case, it tells me George Washington was a famous 18th century North American hemp cultivator. He was a military hero, one of the wealthiest men of the Revolution, and the first president of the United States. So here when I ask for the first president of the United States, notice how that matches all of the keywords that are coming back as the response there. Right, so that's probably what it found as its best match and returned for me as an answer. Now, I can also ask off the wall things, but it wouldn't be able to actually provide me a good answer. So let's say I do, what is today's weather like? So that took a while for the server to actually return back a response. And it tells me like a planet around a star. Again, able to find its best match. It doesn't really realize what it is that I'm trying to ask it because it's not breaking down my text to analyze for intent. And it also probably doesn't have the data for today's weather, right? I can ask things maybe regarding the solar system. So how many planets are there in the solar system? And it can tell me that there's 9 planets. So its accuracy very much depends on my question. The more vague question that I ask, the less likely it's able to return a good answer, which is a similarity with something that happens within ChatGPT. All right. Does anyone have any questions over anything that I've covered up to this point? So far, we've covered what traditional chatbots look like, what is AI, and what Eliza and Alice are. So Eliza being a retrieval, or excuse me, a rule-based chatbot, and Alice being a retrieval-based chatbot. Does anyone have any questions over this content so far? Okay, it doesn't seem like we have any questions, which I'm glad to hear about. Um, Now, let's go ahead and move on into what generative chatbots actually look like. All right. So generative chatbots are a little bit of a monster. They can actually create their own text and generate their own text. Not only are they able to do that, but they are capable of learning through previous interactions that they've had. And you'll realize that as ChatGPT gets older, it's only becoming more and more efficient at providing answers. The more people use it, the better interaction you'll have with it. If you actually sign up for a GPT account and you continuously use the same exact format or information to interact with GPT, it's actually going to be able to realize what your tech stack is. If you're talking to the tech, it'll be able to realize what kind of intent you have every time you ask a question. There's a lot of information that it learns randomly. For example, nowadays, if I try to log into ChatGPT and just ask a general question as to, let's say I ask it, how do I utilize a Docker container? Its example for a Docker container would likely include Django and React and try to show me how it works within a Docker Compose at some point. Now, why? Why out of all the frameworks would it utilize Django and React? Well, it's because I've ran quite a bit of Django and React code through this model. So through all of my interactions that I've had with it, it's determined, hey, this person usually likes to see code inside of Django or React. So it's going to provide me code inside of Django and React. Now, let's take a look at this learning model and how that breaks down a little bit. You'll notice that this also looks quite a bit like machine learning, and it's utilizing a neural network to be able to learn. These keywords don't necessarily have to mean anything to us just yet. We'll learn about them as we continue on with this module. Now, it receives a text. So what are your hours of operations? Now, a machine doesn't actually understand text, and it's not able to learn from text. But what it is able to learn from is math. It's able to continuously run percentages, learn accuracy that way, change something called weights and biases, which you'll see inside of every single one of these tensors inside of a neural network, otherwise referenced as a neuron. So what it does is it breaks down my text and turns it into a numerical number, more than likely a floating integer that's less than zero. And after it breaks it down, it feeds it through a model. Now that model then creates connections with what's called a neuron. And you can see that every single one of the input neurons relates to every single one of the neurons later on. This process continues, and these weights and biases are essentially just running math, running calculations, trying to figure out, hey, why is this text inputted here? What is this? What does this number mean? If this number passes some sort of bound, we need to reset it back to a one. And by the end of our neural network, it would come out with a certain number of possibilities. So let's say these are all the different possibilities that it has. Well, as it comes out with all of those different possibilities, it tries to determine which one of them would be the best match. And through this process, it would come up with an answer saying hours of operation are between 7 to 5. Now, the data that is required to run within an OpenAI model is considerably massive. A lot more, there's a lot more data that falls into OpenAI than it does into Alice or Eliza. But it's also a lot more flexible and dynamic because of the process that it is learning through by leveraging machine learning. It's constantly trying to learn how to best achieve the right answer. When the first models of GPT came out, they were wrong sometimes. And when those models were wrong, you could simply just tell it, hey, you are wrong. The models to this day, they are so, I don't want to call it desperate, but they are so focused in finding the correct answer that they can go through a process called illusion, or excuse me, they can hallucinate, where they will tell you that something is true and try to give you information for something when it's actually not correct. And it does that for code as well. If you're ever asking GPT to generate code for you, don't always count on it running on the first try. Usually there's an iterative process through responses and having to interact with it as to building your request to be able to achieve your correct answer. A pretty good example of this is, let's say we take last week's content and you ask it to stand up a Flash server that connects to a SQL database. Well, it might be able to give you the majority of the information to include the code, excuse me, but unless it knows what kind of operating system you're in, the technicalities as to what are the date up to date nowadays requirements for each one of the libraries that you're installing, it's not going to be able to provide you a proper answer. It will give you about 75% or 80%, or who knows, maybe sometimes it gives you something that runs on the first try. But always double check it and ensure that you're understanding the code that it provides for you. Now, here in Code Platoon, we ask you guys not to utilize AI as much as possible. But if you are doing it, make sure that you're doing it in the right way. Don't copy and paste code. Make sure you truly understand it. And if you don't understand it, don't copy and paste it. Pull over a TA or an instructor. We'll meet with you guys and we can break down the code together to make sure that there's an understanding before you actually utilize that code. Now, we've all seen already interacted with some sort of AI model to this day, whether it be a rule-based chatbot, a retrieval-based chatbot, or OpenAI, which is a generative chatbot. Now let's talk about the differences that breaks everything down here. So a chatbot is usually classified by its conversation and response generation. Now, if it's able to achieve an open-ended conversation, then it's going to fall under a generative chatbot. If it's only a closed conversation, like Alice and Eliza have, then we're looking at either a retrieval or rule-based chatbot. You can see that both of those are impossible. Response generation is still impossible for both of these. But role-based chatbots are actually able to provide a response that comes either from rule-based, meaning that they already have a set type of responses that they can return to. That has already been determined. They're not actively learning, nor are they actively generating a response. Now, generative chatbots are on the opposite side of that. They're actually utilizing artificial intelligence, and they have something called Spark Machine, which is essentially machine learning plus transformers and a couple of other things that they can utilize to be able to actively learn and generate text. And that's how we ended up with chatbots like ChatGPT nowadays. That's the entire history of chatbots. And hopefully this gave us a background as to how AI has evolved over time and all the information that we are about to consume over the remaining of this week. All right, at this point, does anyone have any questions over part one of our lecture? Let's hear it, Bryson.
Is when you say open domain, is that just like free range of the internet?
It's a great question. So instead of domain, just think about it as far as what kind of conversation I'm able to have. So for example, you and I right now, you just asked me a question and I was able to actively think and come up with an answer. we could switch up the topic of the conversation right now, and I would be able to adapt with that and also switch up the topic of the conversation. Right? Well, ChatGPT or a generative chatbot is able to achieve something like that, whereas role-based and retrieval-based chatbots cannot, right? They are within the scope of accomplishing a task. Does that answer your question, Bryson? Okay, I see the yeah. All right. Any other questions? Okay, awesome. Doesn't seem to be any other questions. So let me go ahead and stop our recording here.